now that we know what a chemical equation is, we can talk about how to balance chemical equations. So first I like to start off using a method with drawings. So if we begin with some drawings, the rules are that when you're dealing with particle drawings, you can draw additional reactant particles, but it has to be identical particles to what you already were shown as reactants. You can draw additional product particles, again, the same type as that are already present. And you can repeat that until you have the same number of each type of atom on both sides. So we're going to individually count the circles of each color and until it's bonded. So let's sort of step through this example. So I have iron atom with an oxygen molecule, so it's two oxygens together, stuck together. I know they're stuck together by that subscript of a 2. And then I have Fe2O3. How you draw it at this point isn't particularly important, but there's 2 green iron atoms and 3 O oxygen atoms. Okay, so I'm going to first look at the counts. I see I have 1 iron on the left and I have 2 irons on the right. And I have 2 oxygens on the left and 3 oxygens on the right. So this is not currently balanced because they do not have the same number. Okay, so the first step I'm going to do is I'm going to balance the red atoms. You can start with either one, so it could have begun with starting with the iron. I just started with the red atoms. So I noticed that originally I had only 2 on the left and 3 on the right, so I needed more on the left. So I add another one. Again, I can add additional reactant particles, but they have to be the same type. So I can't just add 1 oxygen atom because this is the only reactant I have is O2, so I have to show the same type. So 2 oxygen atoms bonded together. So 1 was too few, that was 2 atoms total, and now that I have 2 oxygens molecules, I have 4, so it's too many. So I'm going to stop now that I have too many, and I'm going to go to the product side and balance it there. Okay, so on the product side, I'm going to add another Fe2O3 so I can get more red atoms. And now I have a total of 6 red atoms on the product side, but only 4 red atoms on the reactant side. So now that I have too much on the product side, I'm going to stop and go back to the reactant side. So now I add 1 more oxygen atom, and now I happen to have a balanced red atom. So I have 6 total of the oxygen on the left and 6 on the right. So note that if you go back and forth up to 3 times, they will finally balance out. If it takes more than 3 times, that suggests there's some kind of circular reference, that there's an issue. Probably the chemical reactants, the actual chemical formulas aren't right. Your particle drawings, something's wrong with them. So up to 3 is good. After 3, you're spinning your wheels. Okay, so now I have red balanced, but I don't have the green balanced. Finally, I'll go back and I'm going to balance the green atoms. I think I wrote gray, but they're really green. So I have 4 on the left, so I'm going to need 4 on the right, so I need 4 on the left, so I'm adding in 3 more iron atoms. So now I can see that the total of green atoms on the left is 4, and the total on the right is 4. The total of red atoms on the left is 6, the total on the right is 6. Additionally, they are all representative of the chemical formula. Fe suggests they are individual atoms of iron. O2 suggests that there are 2 oxygen atoms bound together per particle. Fe2O3 means that each particle has 2 green and 3 red. The last thing I'm going to do is I'm just going to count out how many I have of each particle and put that in front as its coefficient. So I have 4 iron plus 3 oxygen makes 2 Fe2O3. I'm starting this way. Many of you have not learned this way. You've learned another way to do it algebraically. There's nothing wrong with that. But this way, we really see what is the point. What does that coefficient mean? It's telling me that how many particles. What does the subscript mean? It's describing what one particle looks like, and it's representative of what we are told the reactant is. And this becomes important because one thing that people do wrong a lot in balancing chemical reactions is they try to change the subscript, and you can't. The only thing we can do when balancing is to change the coefficient. So let's look at what we'd do if we're going to start with a formula. So rules are pretty similar. We're going to start with a coefficient of 1 for each reactant and each product, and we're going to count out how many atoms we have of each type of element. So just like we counted the green and the red, now we're just going to count them symbolically. So to count the number of atoms for an element in a compound, you multiply the coefficient that's there, in 1 in this case, times the subscript for that one element. If I have an element present in more than one compound, I'm going to add them all up for all of the atoms for one type of element on each side of the equation. So if I have oxygen in two different reactants, I'm going to add the oxygen from the reactant 1 to the oxygen for reactant 2 to get the total number of oxygen atoms. Same thing on the product side, and I'm going to do this for all the elements. And then I'm going to look, if they're not balanced, I'm going to adjust the coefficient of a substance on the side that has too little atoms of that given element. So I pick one element to start balancing, just like we did before. We started with the red atoms. Now we're going to pick one of the elements in there, and I'm going to change the coefficient on the side that has too few of those atoms, that element. And I usually just I started with 1, I just try 2, try 3. Sometimes you'll get a number sense and know which number to try. And you're going to try until the total number of that type of atom is the same on both sides. Now I may have to go back and forth. If I change the coefficient and now I have too much on the product side, I have to go back to the reactant side and change that coefficient for the substance until I get them balanced. Again, up to 3 times, I might have to do it till I get it balanced out. And then I repeat that for the next element until I've done that for all elements. The big thing is do not adjust the subscripts. The subscripts are representative of what are the chemical reactants and products that we were told in this reaction. And so I can't change them. That is the substance that is undergoing the transformation. I can't change the subscripts. I can change the count. That is fine to do. So only change the coefficients. Okay, so here's an example. H2 plus O2 makes H2O. So if I do a count starting off, I see that I have, remember, for hydrogen on the reactant side, this is the reactant side, so I have 1 coefficient of 1 times 2 its subscript to get the 2 for the hydrogen, and 1 times 2 to get the 2 for the oxygen. On the product side, for the hydrogen, that's the first row, I have a 1 times a 2, because the subscript for the hydrogen is a 2. But for the oxygen, it's a 1 for the coefficient times a 1 implied for the subscript of the oxygen in H2O. So that's just 1. So again, now that I have my count, I'm looking to see which is the element where is the count low. So since hydrogen is currently balanced and oxygen is not, and the product side is low in oxygen, that means I'm going to change the coefficient on the product side. So I have 1, I need 2, so I'm going to try using a coefficient of 2. So I've identified that this is the one that's off. So now I'm going to have to update the counts, but I have to update it for both hydrogen and oxygen. So a coefficient of 2 times 2 gets me, well, okay, so a coefficient of 2 times the implied 1 subscript of oxygen gets me 2, and for hydrogen, it's 2 times 2 gets me 4. So now I go back and check. Now oxygen is balanced, but hydrogen is not balanced. So now the reactant side is the side that's low. I'm going to go and adjust it. Currently I have 2, I need to get to 4, so I'm going to need a coefficient of 2. So this is the low side. I'm going to put a 2 in front. 2 times 2 is now 4, and now I have 4 hydrogens as reactant and 4 as product. 2 oxygen as reactant and 2 as product. It is a balanced reaction. Just a few hints. Again, make sure that all of your compounds are valid formulas. We haven't really talked about compounds, but a lot of times if you write the formula wrong, then it's never going to balance because it's not legitimate. So make sure that it has proper subscripts. In this case, from at the beginning of the course, make sure you've copied it down properly. Later on, make sure you've come up with the proper chemical formula for the substance that's involved. Remember that the count is the sum of all the coefficients times the subscripts for that element on one side of the equation. Never change the subscript, only change the coefficient. Also, we usually leave, you remember we said you can pick any element to start with. Do not start with the oxygen or hydrogen in general because they tend to be in more than one substance, and that can be a little bit confusing. You're not sure which one to change. If it's in more than one reactant, which coefficient do you change? So if we leave them to last, it turns out they get determined by the other ones and it all works out. So I usually leave them for last. Okay, so to practice, try balancing these reactions.